Not only are you awesome, but you're also terrific. Whoa, I got two of those cones. Okay, so thanks for finishing off. We're just finishing on 15 here. And so negative 12 times 4 is negative 48. But what? Pause me. You try on your own, remember? Pause me. Try on your own. That's the best way to learn. You're not going to learn very well if you don't pause me. So pause me, try on your own. Push play, see how you did. Then pause me, try the next one. So what's a times a squared? What's that? So, well, a times a squared is technically a to the first power times a squared. And so you're just going to add the powers. So we get a to the third power. Then we have b to the first power and b to the fourth power. Add those together. And we get b to the fifth power. Bring the c with you. Beautiful. So you try 16 on your own. Remember that there's two of them. Remember that there's two of them. Don't forget to do the smiley face. Nose in the mouth. Don't forget the smiley face. That's it. Okay, so then we'll jump over here. Keep on going. Okay, so now when we get to fractions, things can, you remember we added the powers? So now when we're doing division and fractions, then we can actually go down and we can actually not add the powers, we can actually minus. We can actually minus the powers. So don't forget to minus the powers. Yeah, we can minus the powers, right? Minus the powers. Okay, let's see here. So first, we could multiply this one out, actually, and then we can minus the powers. Why don't we do that just in case we don't make a mistake? Because I'm worried you're going to minus those too soon. Don't do it yet. Okay, so let's multiply, which means add the powers first. That's actually going to be add. It's actually going to be add the powers first. So then we get 5, and then x to the fourth times x squared. So we're going to add the powers. Good. And then now we're going to multiply the powers. Actually, now we're going to multiply those powers. Because it's an exponent to an exponent. Multiply the powers. Multiply. So then 6 times 2 is 12. So now we get 5 x to the 12th power. Okay, that's getting crazy. Okay. So then we're going to go ahead. 5 divided by 5 is just 1. Goes away. So now technically, right? So we have 6 of them on the top. Okay. 6 x's on the top. And then we have 12 on the bottom. That's crazy. We have 12 on the bottom. So to show you that we have 12 on the bottom, I'm going to introduce my infinite cloner. Whoa, you have an infinite cloner? Wish I could clone money. Oh, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 on the bottom. So, right? So we're doing division right now. We're doing division. And so we're gonna go 1 with 1, 2 with 2, 3. We're canceling x's on the top and the bottom. And so 6 on the top is going to cancel with 6 on the bottom. So what are we left with in the bottom? We have 1, 2, 3, 4, 5, 6. Now when we say cancel, there's still an invisible 1 there, okay? So let's do that in red. Still an invisible 1 there when we say cancel. So we're going to have that 1. So 1 over, and then we have our x to the 6th power. Ooh, that was a good one, you guys. That was a toughie. That was a toughie. So try 18 on your own next. Don't forget the negative means to change it positive and bring it up to the top. So I'll show you what I mean with number 19, okay? So first, we're going to distribute the 2 through to everywhere. So we get 4 squared, and 4 squared is 4 times 4, because 4 squared is 16. And then we have x negative 3 times 2, which is going to be x to the negative 6th power. Interesting. Multiply powers. And then y squared. Good. All over. And then we have 12x squared. But that y to the negative 3 is going to do something weird. Okay? It's going to do something weird. So basically, here we go. We learned in class that when you have a negative exponent, right? When you have a negative exponent, what do? Do you remember? Pause me. Say it out loud, then push play, see if you got it right. When you have a negative exponent, you move it up or down and change to positive. Oh, I could do that. I could do that. Are you sure? Okay, give it a try. Pause me then. You try on your own. You try. Behind the screen. You try on your own. Okay, so let's try it. So I'm going to take this y, -3, and I'm going to bring it up to the top, times y to the +3. A +3. Right? Make it a +3. And then we're going to make this positive, but we have to bring it down. So we end up with 16 y squared times y to the 3rd power on the top. And then the bottom we end up with 12 x squared. And then this guy right here goes down to the bottom, but we make it positive. So that's going to be a positive x to the 6th power. And now we have the same base, so do we multiply or add the powers? Do you remember? Multiply or add the powers? So we are going to add them. Remember, same base, we add the powers. So that's going to be y to the 5th power on the top. And on the bottom, it's going to be 12. And then x squared times x to the 6th power. No, we add the powers. So x to the 8th power, 2 plus 6. 2 plus 6 is 8. We add the powers. And then can we reduce it? Yeah, we can reduce it. 4 goes into 16, and 4 goes into 12. So we'll divide by 4. And so our final answer is going to be 4y to the 5th power. And what is 12 divided by 4? It's 3. X to the 8th power. There we go. So give that a try. With number 20 now. Give 20 a try, very similar. 21, you're going to distribute the powers. Right, and then try 22. So you end up doing 4 to the -3rd power. You end up doing a to the 5th power. But then that's going to be raised to the -3 power. We're just distributing that -3. And then b to the -2 is also going to be raised to the -3rd power. Good. And so we end up with 4 to the 3rd power to the -3rd power. What the heck is that? So 4 to the -3rd. Well, first we got to change all these. You guys are, well, not all of them are negative. Let's see. So let's go ahead and erase that for now. I should really let you try that one on your own. No new will help us. Okay, well, pause me. Try it on your own first. Okay, so technically, what is that going to be? That's actually going to be 1 over. Okay, it's going to be 1 over 4 to the -3rd power, which is 4 to the +3rd power. And 4 times 4 is 16. And then we're going to times that by 4. And so that's going to be 64. Right? So you're going to end up with, this goes down to the bottom, you're going to end up with 64 in the bottom. And then 5 to the -5 times -3 is -15, which is going to be brought down. So that's going to be a to the +15. And then -3 times -3, -3 times -2 is a +6. And so our final answer is going to be b to the 6th power. I need to draw my b's better, but I'm using my mouse. Sorry. So that's b to the 6th power all over 64, a to the 15th power. Nice. You try 22 on your own. Properties of exponents, you got this. Right? Okay, so now use properties to solve. Let's make sure we're doing okay now. Okay, we're almost there. Okay, to solve. So remember that you add the powers. So we're going to go x to the 2r minus 5. And then you're going to add the 12. Okay. And then 12 minus 5. What's 12 minus 5? That's 7. So we get x to the 2r plus 7 equals x to the 3rd power. Now, it doesn't matter what x is at this point, right? So x could be a 3. X could be a 2. It doesn't matter because basically the left side and the right side are going to be the same base. And when you have the same base, you can basically cancel and just focus on the exponent, solving for the r. Another way that I like to teach, because technically it's true, is that it's a logarithm. And you can log base x both sides, and that'll actually get rid of the base x. But we're not going to teach that until logarithms. Just know that if you have same bases on either side of equal side, then you can cancel your bases. It is using properties of logs, but I don't want to confuse you too much there. But yeah, so that's basically some notes you could write down in your notebook. If you have the same base on either side, you can cancel the bases. Right? Nice, nice. Okay, there we go. And so because we can cancel the bases, we're just left with 2r plus 7 equals 3. So now we go ahead and move this out of the way. Okay, so then we're going to go ahead now and we're going to do 2r plus 7 equals 3. And now we're just going to solve for r. By getting everything else to the other side. So we're going to minus 7. And so negative 7 plus 3 is what? Negative 4. Good. And then we bring down the 2r. And then we simply divide by 2. Divide by 2. And when you do that, you get r is equal to r is equal to negative 4 divided by 2 is negative 2. And that's our final answer. Good job. Show your work. Good. So you try 24 on your own. And for time's sake, try 25 on your own too. But don't forget to distribute, right? Because we're multiplying. And then after you do that, I can do 25. Pause me. No, you pause me. You try on your own first. Right? Oh, I made a mistake already. So that's supposed to be a 6 because 2 times 3 is 6. And then do you remember what we do with our bases? Do you remember what we do with our bases when they're the same and we're just focused on the exponents? We can just cancel them out. Just cancel them out. Cancel your bases. So then we're left with 2r plus 6 is equal to 5r minus 6. I'm trying to solve for r. So r, so I'll minus the 2r to the other side to get all the r's on the same side. And then we'll go ahead and add 6 over to this side. And we get 12 equals, what's 5r minus 2r? 5 minus 2 is 3. R comes along for the ride. And then last but not least, what do we do next? We solve for r by dividing by 3 and dividing by 3. And so we do get r equals 4. Did you pause me? Did you get that on your own? Pat yourself on the back if you did. Last but not least, here we go. Kevin bought a candy bar. He ate only 2/5 of it, and he gave the remaining candy to his 2 best friends. So what fraction will each of his friends receive of the candy bar? That's so sad. It's a big candy bar, that's why, okay? It's huge. So 2/5 of it. So if he ate 2/5 of a candy bar, right, how much is left of that candy bar? Right? If he ate 2/5 of that candy bar, well, you had 5 parts to that candy bar, okay? If you divided it into 1, 2, 3, 4, 5 parts of it, and so he ate 2/5 of it. And so how much is left? There's 3/5 left. Now that's not our answer. They want to trick you on the ACTs. That's not our answer. But what we can do is we can take that 3/5 and now we're going to divide it. We're going to divide it over 2 friends. So we're going to divide by 2. And what's another way to divide by 2, right? What's another way to divide by 2? Is to cut it in half, right? How do we divide by 2? We just cut it in half. We keep, change, flip. We just cut it in half. And so when we cut that in half, we get 3/10 as our answer. Everything is awesome. Thanks for watching. See you on the next one. Keep on going. You got this. I believe in you. Thanks for watching. Bye for now.